All right, so day 3, we're just going to start by doing another one like we just have done on day 2. Just quick rewind and recovery. Okay, so Spezio's class wants to estimate the mean mass of Snickers fun size bars. So that's what our funky U is going to be. Okay? They randomly selected, so random, that's important. Randomly selected 54 bars. The bars had a mean mass of 17.1. The more often you get used to doing these underlines, the better. Standard deviation of 0.76. And we're looking for a 95% confidence interval. That's the key information. So number 1, we just start saying our funky U is the true mean mass of Snickers fun size bars. Okay? That's it. Number 2, check conditions. Random, question mark, given. Okay, it was given to us. Yes, it was random. It does not tell us, it's normal. We don't know that, being told that. But we do have 54 bars, which is greater than or equal to 30, so check. We're good to go. 54 is greater than or equal to 30, we're good. Now we simply do the math. Sort of. Okay, let's see if it wants to write. There we go, number 3. The math. Again, we're doing a 95% confidence interval. Okay? It said our mean mass was 17.1. Always plus or minus. We'll fill in the t-score here in a minute. The standard deviation was given to us. It was 0.76. All right. The number of bars was 54, so that's the square root of 54. Our degrees of freedom is 53, but we have to drop it down to 50 because there is no 53 on the chart. So we're going to look at our chart at the intersection of 95% and 50, which gives us 2.009. So we take our calculator and we do 0.76 divided by the square root of 54, enter, we get a decimal, and then we're going to multiply that by 2.009. And we get 0.207 to 0.208, we'll just run it to 0.21. So that's 17.1 plus or minus 0.21. We subtract, we get 16.89. We add, we get 17.31. Number 4 is our statement. Very simple statement. We are 95% confident that the interval from 16.89 to 17.31 captures, and then you just fill in what we wrote at the beginning, the true mean of Snickers fun size bars. I can spell. We'll try that again. Snickers fun size bars. That's it. All right. Now, we have done something like this before. In the previous unit, we figured out backwards how many people were needed in our survey to have a certain number. Okay? We're doing the same thing here, but it's going to be much easier. It's a smaller formula, and it's much quicker to do. All right? So, we're going to work backwards. It says, suppose we wanted to estimate the average height of RSHS students within 0.5 inches. Okay? That's our margin of error. Okay? 0.5 inches, plus, that's our error. All right? How big of a sample do we need? So how many students do we need to be within that with 99% confidence? Now, here's the problem. Our t-score is based on the number of people. Because to find the t-score, we need to look on the chart using degrees of freedom. But degrees of freedom is based on the number of people. So we're kind of hurting there. And we don't have standard deviation yet either. Okay? Some of this will be given to us. So, suppose we have an initial survey of 10 students. That suggests that the standard deviation is 2.3. All right? How many additional students do we need? Now look here. It says if we don't know the value of standard deviation, we can use a previously known value or do a preliminary study. That's what they did here. They said just based on these 10 students, we have a 2.3 standard deviation. So we're going to use this standard deviation from a little mini sample, okay, to use on our new one. So we know that our margin of error is 0.5. We don't know the t-score. We're going to come back to that. We're taking this previously used standard deviation and putting it here. We're trying to find this. Now, everybody needs to look at their t-chart again. Okay? Look down at the bottom. We talked about this last week. If you look at the very bottom, after 1,000, you'll see an infinity symbol. That's actually the z-score. So if you remember before when we did z-score, and we used numbers like 2.58 for 99%, look at 99%. It's 2.576, right? That rounds to 2.58. That's the z-score for a 99% confidence interval. So we're actually, since we don't have enough information, we're going to use the z-scores from the infinity row. So we're looking at 99%, and we have that, so we're going to use 2.576 here. Now, we're going to crunch the numbers. This is really over 1, so we're going to multiply and get 0.5 equals 5.9248 over the square root of n. Now, we've talked about this shortcut before. Technically, the next step is to multiply both sides by square root of n, which means on the left side you'd have 0.5 square root of n, and then you have to divide by 0.5. But at the same time, all we have to do is switch places. That will make life easier. So we can just write now square root of n equals 5.9248 divided by 0.5. Which is the same thing as multiplying by 2. So dividing by 0.5 is the same thing as multiplying by 2. So the square root of n equals 11.8496. That's 59248 double. How do we get rid of a square root? We square it, which means we square this. So n is equal to 140.41. We round up to 141. Now that's not our answer, because it said we had an initial survey of 10. How many additional students do we need? Well, if our goal is 141, and we started with 10, 131 students. more. So we need 131 more students to reach that 141. Okay, same thing. Body mass index of all American young women is believed to follow a normal distribution. That's nice to know. Standard deviation of about 7.5. How large a sample would be needed, plus or minus 1, that's our margin of error, 99% confidence interval. So this one's really easy. The margin of error is 1. We don't know our t-score yet, we're going to look that up. We don't know the square root of this, but we do know that 7.5 is our standard deviation. So we go to our chart. We already know it, so we already looked it up. Because we're doing 99% confidence again. So it's at 2.576. All we're going to do is multiply those. So we get 2.576. Did it again. Okay. So we're going to multiply 2.576 times 7.5. Which is 19.32. Remember the shortcut, just switch these two. So the square root of n equals 19.32. And I'm not going to bother writing it over 1 because, well, it's over 1. How do we get rid of that? We square it, and we square that, which gives us n equals 373.2624. We go up to the next person, 374 people. That's how large the sample size needs to be to satisfy those conditions.